Welcome to My Ramblings. This episode, my book, the NEC. The NEC, it shouldn't be, but it really does become a controversial topic sometimes. And, when I first entered the PDC internship, my first supervisor was a GS-13 supervisory electrical engineer. He's the one that helped set up all my rotations. He gave me a lot of information, a lot of things to study. Made a lot of resources available to me. Plus, there was another guy there. It was a 12, I think, and he was sort of a mentor. He tutored me through a bunch of stuff. It was useful. When he got to the per unit analysis, I mean, you see that in lower division, and then you see it heavily in power system studies. And, okay, I'll get another take on it. But, I wasn't going to tell him, hey, don't tell me nothing. But yeah, he was a good guy, and he learned to be a lot, we'll say. But well, he's the guy that told me, hey, don't go to design. A lot of people think you can learn design like that, but it really takes 15 years or so to develop the skills to be a proper designer. A lot of people argue at that. And my supervisor, he mentioned the NEC. He didn't go into it. He just said that, okay, I'm going to give you a copy of the NEC. Don't worry about it. Don't try to, don't read it. Just hold on to it. And at some point, you may start getting exposure to that. Never really did, though, until I got to the design and engineering department. But one of the most important things that he told me is that just remember, though, it's not a design manual. You need to know a lot to really understand what the book is telling you. And if you actually open the NEC, it says this is a fire protection standard. It's meant to minimize shock, and it's meant to minimize the potential for things catching on fire. This is not a design manual, and it's not meant to be used by people who have no experience. It doesn't say no experience as an electrician. It doesn't say no experience as an electrical engineer. It doesn't say no experience as a designer. It just says it's not meant for people who have no experience. Okay, so the trouble is that almost everybody who wasn't an electrical engineer seemed to think the NEC was a design manual, and that it was all that was required for an adequate electrical design. I was talking to when they had us moved out, waiting for we had a little bit of time on our hands, and was talking to a structural engineer. He seemed convinced that the NEC was all you needed to design electrical systems. And I said, well, it's not really. That's not what it's intended for. It's not what it says it is. And he ended up showing me a copy of the structural code books that he used, and they were a lot more prescriptive. You could make an argument that that was a design manual, a prescriptive design instruction. I mean, you had to know that you were going to put up a post, obviously, in order to meet the criteria for sizing the post. And in a lot of ways, the National Electrical Safety Code, which governs installations for electrical utilities, is kind of a design manual as well. It's meant as a safety standard, but it doesn't actually tell you how to do sag and tension. It doesn't actually tell you how to do pole strength calculations, but it provides all the criteria, like, if you live in a certain region, you have to account for so much wind loading, and you have to account for so much ice loading and stuff. But the NEC is different. There's a lot of examples you can take where you did something per the NEC, and the NEC worked because a fire didn't start it. You burned up your machine. The equipment wasn't usable again. And you could go into that. I took an industrial analysis course, and they spent a lot of time on the basis of ratings and stuff. And a lot of people don't realize, if you don't look at the criteria to which stuff is manufactured, that there could be some issues. Like if you have 9,000 amps short circuit available, and you choose a 10,000 amp circuit breaker, if that thing's only rated to handle 2 trips at its maximum trip, near its maximum trip rating. So would you have a 9,000 amps for a circuit? Well, if it was way down the line in a branch circuit, no, you wouldn't. Maybe if it was inside the panel board or just after a short length of feeder cable, then yeah, you probably would be pretty close to that maximum 9,000 amps. And then the trouble is if you experience 2 of those and you have no idea where your faults were, if you weren't keeping track of how many, then basically now you have a breaker that is beyond its designed and manufactured intent. You don't know if it's going to trip or not, because it wasn't designed and manufactured for 100 trips. If you had 4,000 amps available, I can't remember exactly what the standard says. You probably get 100, 200, maybe 1,000 trips out of it. You really have to read the standards to find all this out. And so this is first in the series of the NEC, the controversial topic of those that say that the NEC is sufficient for any and all applications, and those who recognize it for what it is. Its purpose, its stated purpose, is to minimize shock to people and to minimize the possibility of a fire. So I hope you enjoyed this episode, and see the next one. It's not as nice.